Good day everyone, my name is Ijan Bautista and this video is for educational purposes only regarding glass analysis. So before we start, let us first describe what is glass. Glass is a hard, brittle, non-crystalline, and more or less transparent material that is used in numerous applications in our daily lives. Glass is made from a natural and abundant raw materials such as sand, soda ash, and limestone that are melted at very high temperature to form a new material which is glass. So let's proceed to glass as evidence. Glass or glass fragments serves as physical evidence of a great value for the investigation of many offenses such as the burglary, arson, hit and run cases, shooting, and assault. A large variety of physical evidence is included under the term trace evidence. Like if a window or glass object is broken or shattered by a projectile, such as bullet, the breakage pattern can be analyzed to possibly determine the angle of trajectory of the projectile, shedding more light on the crime, such as where the suspect was and when was the gun was fired. In order for us to get a sample to study, together with my members, we use an improvised gun that requires air in order to fire. And due
Nice.
to the current situation of the glass, we only did 2 shots because if we continue, the glass will not be able to sustain the third shot, which will result in breaking, and if it survives the third shot, maybe it might break in the middle of our departure. And this is the sample we made. It's very fragile. It needs to be taken carefully. It's hard to take a risk because it might break. So it's better to lie down the glass while we're studying it. So this is the entry point of the projectile or the load side. It contains 2 penetrations. The upper hole is the penetration number 1 and the other at the bottom is the penetration number 2. Each penetration leaves a hole. In the center of each hole is where we can find the point of the impact. Point of impact is where the force is applied that makes the glass break in an opposite direction. In the fracture patterns will be visible on the surface. If a projectile will not successfully penetrate the glass, the fracture that will only form is the radial fracture. Radial fractures are the primary fracture that radiates outwards from the central point of the impact, and it resembles a spike of an arching or spikes of a wheel. Determination of the radial fractures requires a rule, and it is the 4R rule. The ridge line on radial fractures are at right angles to the rear. This means we can determine the radial fracture to the opposite side or the unload side of the applied force. The best way to determine the radial fracture is to feel its roughness by touching the radial lines. Once you feel that the surface is smooth, then it's the load side. However, if the opposite side is rough, then it is the radial fracture in exit point. This primary fracture was created due to the projectile that hits the surface of the glass that makes the glass stretch, causing tension on the backside directly behind the projectile. This causes compression around the point of tension. The radial cracks begin on the opposite side of the force at the point where the projectile hits the glass and radiates out from the origin of the impact, continuously to the far surface. Somehow, if the projectile successfully penetrated the glass from the point of impact, it will radiate fracture outwards. Then if the elasticity of the glass reaches its limit, it will create a hole. Afterwards, the secondary fracture will form, resembling a shape of a ring, and it's called concentric ring or concentric fracture. Usually, this concentric ring can be observed on the load side or where the force is applied, forming around the point of the impact, and if observed in the unload side, the ring will be formed like a crater. So, this is the concentric fracture connected between radial fractures that results in a fan shape. In successful penetration, we can find the cone fracture. Projectile leaves a round crater-shaped hole which is surrounded by radial and concentric cracks. There is the appearance of a cone as the hole is wider on the exit side, and it's also rough, which gives the appearance of a cone. And we can conclude whether there's an exchange of firing or if the bullet comes out of the car or inside the car. Helps a lot in determining the entry and exit points. Next is the point of termination. As you can see, we have two successive penetration. This happens because of each of the radial fractures. Like for example, penetration number 1 has already radial fractures. After that, the second penetration created also a radial fractures. In some of it that are close to the radial fracture of number 1 penetration will end itself by encountering an existing fracture line. And by observing the point of termination, we can tell what penetrated the glass first or the sequence of impact. So, conclusion. Therefore, we conclude that diameter of the hole of penetration number 1 is ranging up to 30 millimeters to 10 millimeters. There's a big gap difference because the hole is not having a perfect circle due to the reason of the angle of the gun was fired diagonally. The left side of the glass sustained the most damage, resulting not having a perfect circle of impact. Meanwhile, penetration number 2 diameter is ranging up to 12 millimeters to 14 millimeters, having a perfect hole of impact in shot at a 90-degree angle, which means in this two penetration, the shooter's position is far from the target. Because in entry and exit points, the smaller the hole tells the gun was fired in afar. The larger the hole, which means there's a probability of suicide or fired in a close range.